everyone. In today's lesson, we're going to talk about common factoring. This is the backbone of any form of factoring that you are going to be using, and so it's really important that you get it down pat. Factoring is a polynomial, or factoring a polynomial is the opposite of expanding, okay? You are used to problems like this where you had brackets and you needed to use the distributive property in order to expand them. Well, in this unit, we're going to talk about factoring. Factoring is when you need to go backwards. You are given a polynomial and you need to reduce it such that there is something multiplied by something else that gets you to it. In order to determine what to factor out, so how to figure out what goes on the outside of the brackets, you have to consider the numerical coefficients. Okay, so in that case, it would be the 2 and the 6. And you need to consider the variables. In this case, we are dealing exclusively with x's. Particularly, you need to consider how many of each variable you are presented with. For example, I have an x squared here, as in there are 2 x's. Here I have an x, there's just 1 x. You need to consider how many of each variable you have when you are going to factor. Basically, the question that you are going to be asking yourself is, what do all of the terms have in common? There are 2 steps to doing this. Step number 1, determine what all terms have in common. Step number 2, determine what's left. In order to do this, you are going to use your greatest common factors, your knowledge of that from elementary school, as well as your knowledge of just general dividing variables. Let's look at our first example here. 2x plus 4. We need to figure out what these terms have in common. The first thing I'm going to consider is I'm going to consider the numerical coefficients, and I'm looking for the greatest common factor between 2 and 4. In this case, the greatest common factor is 2, so I'm going to write 2 first. I also need to consider if there are any variables that these terms have in common. My first term has an x. My second term has no variable. And therefore there are no variables that these terms have in common. So I'm just left with a 2. I'm just going to open up a bracket, and on the inside of the bracket I'm going to put where everything else goes. So on the outside of the bracket, this is what I managed to factor. On the inside of the bracket, these are my leftovers. So 2 is what was in common with both terms, and now I need to figure out what is left. In order to do so, I'm going to take each term and I'm going to divide it by what I have factored out. So I'm just down here, I'm going to do 2x divided by 2, and I need to do 4 divided by 2. Well, 2x divided by 2 is x. 4 divided by 2 is 2. Therefore, what I have left in my bracket, what the leftovers are x plus 2. Now, if you want to think about expanding this and going backwards, just double checking your work, that's a great idea. 2 times x is 2x, so my first term is correct. 2 times 2 is 4. My second term is correct, and therefore I have factored this correctly. Let's look at a second example here. 2x squared plus 3x. Again, you need to be asking yourself numerical coefficients as well as variables. There are no common factors between 2 and 3 other than the number 1, and it's pointless to divide things by 1, so I'm just going to leave them. However, I need to consider if there are any variables that these terms have in common. I can see that both of them have an x. X squared, which means that there are 2 x's, and 3x, which means that there is 1 x. So I have x squared and I have an x. They both have 1 x in common. I can't say that they have an x squared in common because my second term does not have an x squared, it just has an x. However, my first term has an x and it has another x, so I know I can factor out at least 1 x. We've already done the numerical coefficients, so I'm going to open up a bracket here. Now it's time to find my leftovers. Recall that we have to do the term divided by what we managed to factor out. 2x squared divided by x. This leaves me with 2x, because x squared divided by x is just x. Then I need to do 3x divided by x. X's cancel out, I'm left with 3. So we have 2x plus 3. One way to double check that you're factoring everything perfectly is to make sure that your leftovers have nothing else in common. Okay, so I'm just going to make a little note here. So between the 2x and the 3, there's nothing in common. Therefore, I have factored correctly. If you find that there is something that they have in common that you can factor a second time, that means the first time you did not do it correctly, you did not factor out enough, and you should double check what you were working on. Let's do a few more examples. (16x squared minus 24x). Again, first things first, I need to think about my numerical coefficients. 16 and negative 24. We're going to ignore the negative sign just for a second here and only consider 16 and 24. What is the largest possible number that these two have in common? When you're presented with problems like these, it might be helpful to make a factor tree, so I'm going to do that up here. 16, the factors would be 1 and 16, 2 and 8, 4 and 4. The factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. You can then ask yourself, what is the largest number that is shared by both of these trees? In this case, the largest number is 8. Now, you might have just thought off of the top of your head, well, it's obviously 2, it's obviously 4. But remember, if you don't pick the largest possible number, you're going to be faced with a scenario where what you factor out, your leftovers, they have something more in common, and therefore you need to factor again, and you're just creating more work for yourself. So you want to be sure that we're picking the largest possible number as well as the largest possible variable for when we are factoring. We've determined that the largest coefficient here is an 8, so I'm going to pull 8 out. I also need to consider between my x squared and my x, what can be factored out here? I have 2 x's in my first term and 1 x in my second term, so I'm going to just have 1 x here. You can always consider when you're dealing with variables, which one has the smallest exponent, and then that's what you're going to use. So between the squared and just the x has the smallest exponent. Let's go ahead and fill in the rest of my brackets here. So I'm going to do 16x squared divided by 8x. Well, 16 divided by 8 is 2. X squared divided by x is just x. Then we're going to bring the negative back into the problem here. Negative 24 divided by 8 is negative 3. X divided by x is just 1. So this is my final solution here. Let's move on to the next problem. 8y squared plus 8y. We can see immediately that the coefficients are identical, so I can factor both of those out. I can factor out an 8. I have a y squared and a y, so just like we've been doing, I can factor out an individual y, and I can open up a bracket. 8y squared, let's just do this. 8y squared divided by 8y. My 8's cancel out, and I'm left with 1y. I'm also going to do 8y divided by 8y. It might be your instinct to say, well, I got rid of the 8y and therefore there's nothing there, I just have a y left. But remember what we're doing, we are dividing out. This 8y divided by my factored 8y, well, 8 divided by 8 is 1, y divided by y is 1, so this is just 1. Therefore, y plus 1 is my final solution. Remember, you can always double check by distributing in. If you had written 8y just times y, and you distributed that out, you would be presented with 8y squared, but that was not your whole problem. You also had an 8y here. You always have to remember that you're talking about division. Let's look at a few more problems. 5a cubed minus 4a squared. There is no numerical coefficient that I can pull out here that is a greatest common factor between 5 and 4 other than the number 1, and 1 is kind of useless, so we're not going to do any of those. I have an a cubed and I have an a squared. Remember how I said you can just look for the smallest coefficient. A squared is our smallest coefficient here on a, and both terms have an a in them. There are 3 a's here, but only 2 a's here. So you need to say to yourself, okay, the biggest amount of a's that I can pull from everybody is 2. There's going to be 1 left over, but I can't pull 3 because the second term doesn't have a third one to offer. I'm going to pull out a squared. Now let's fill in our leftovers. I still have my coefficient of 5. A cubed divided by a squared just leaves me with an a. I have a negative 4 left over. A squared divided by a squared is just 1, so it is just negative 4. My solution, a squared times 5a minus 4. Let's look at longer problems here. Remember, when you're factoring, you need to look at each individual term, and you need to consider what do they all have in common. Not just 2, not just 3, all of them. Let's start by looking at our numerical coefficients here. 10, 15, 25. What is the greatest common factor that they have? Well, it's 5. So I'm going to pull out a 5. I also need to look at my variables. I have an x squared, x cubed, and x to the power of 5. The lowest exponent here is a 2. I have 2 x's, 3 x's, and 5 x's. The most that I can pull from all of these terms is an x squared. I can't pull anything more because this first one doesn't have anything to offer. This is my limiting agent. So I can pull an x squared here. Let's open up our bracket. 10 divided by 5 is 2. X squared divided by x squared is just 1, so my first term is going to be 2. Negative 15 divided by 5 is negative 3. X cubed divided by x squared is x. 25 divided by 5 is 5. X to the power of 5 divided by x to the power of 2 is x to the power of 3. So my final answer is 5x squared times 2 minus 3x plus 5x cubed. Okay, our last expression here, arguably the most complex that we've had all lesson, 125xy squared plus 50x squared y squared minus 25xy. Let's take a look at what the factors are that we have to offer here. Okay, I can see and I know that the largest possible factor is going to be 25. I know that 25 is divided into 125, and 25 can be divided into 50. Okay, so I'm going to go ahead and I'm going to pull out a 25 here. I then need to look at my variables. First, I'm going to check to see if each term has an x in it. X, x squared, x. So the answer is yes. I can pull out 1x because that is the fewest number of x's in the terms. There's 1x, 2x, and 1x. Therefore, I can pull 1x from everybody. Let's look at the y. I have a y squared, y. Therefore, I can pull out a y. Again, we're looking at the lowest exponent. In this case, we have an exponent of 1 here. Y squared, and y. There's 2 y's, and 1 y. We know that each term has at least 1 y. Now it's time to find our leftovers. 125 divided by 25 is 5. X divided by x is just 1. Y squared divided by y is y. 50 divided by 25 is 2. X squared divided by x is x. y squared divided by y is y. Negative 25 divided by 25 is negative 1. X divided by x is 1, y divided by y is 1, so this is my final term. And I can double check just at a glance that I've confirmed I have factored everything correctly, because there is nothing that I could pull from my leftovers here. There's nothing that they have in common. I can't pull a y because there's no y on my last term. The only number that I could pull would be a 1, and that's not very helpful. So I can confirm that this is my fully factored form. Just to double check, we are going to go ahead and expand. I'm going to do 25xy. I'm just rewriting the problem here. Let's use our distributive property. 25 times 5 is 125. X, y squared, because y times y is y squared, plus 25 times 2 is 50. X times x is x squared. Y times y is y squared. Finally, 25xy times negative 1 is just negative 25xy, and that is the exact same as our initial question, so we know that we have factored correctly. And that's all there is to it.